Greetings out there in YouTube land. After a long dry spell, an interesting amp finally showed up in the workshop. And it's one of the nicest Blackface Fender amps I've ever laid eyes on. As you can see, it's a Vibro-Champ. It's a 1965 model. Let's take a close look at it. Hey, Rusty. Rusty. Okay. Just relax. Okay, I'll take care of the video myself. Thank you. The grill cloth is just about perfect with a real uniform, nice aged look. The control panel is just about perfect. And you notice right here what everyone likes to see on their Blackface Fender amp, Fender Electric Instrument Company, which is Pre-CBS. This one has the little blue jewel. And also, you know, it's an early one because the set screw is on the 10 rather than on the 1. So this would be a Pre-CBS Blackface Vibro-Champ. Let's take a look at the back. Then we can see that the back is just as nice as the front. The chassis straps have a little tiny bit of surface rust. It's the original little rubber handle. It's got the upper door panel with the original screws, and chassis looks great. It's A030, so 1965. And we're looking at the tube chart, it's OD, so that would be April of 1965. Okay, really beautiful shape. Looks like there's been some patching on the speaker wires. There's no Fender or Jensen logo. And then this was in the bottom. It's kind of cute. First of all, somebody has changed over the 2-wire cord to a little, 79-cent plug. Here's, I guess, maybe the original plug, and a pair of gold bond stamps, which if you're as old as I am, I remember helping my mother lick these and stick them in books to take them down to the store and trade them in on TV trays or other useful things. So that's the rear of this beauty, and it is an absolute, just pristine gem. Okay, now here's the problem. The man says that when he's using this, it gets so hot that you can't even hardly touch the chassis. You can smell the Tolex, it about sets off the sprinkler systems. He's afraid that if he lived anywhere near an Air Force base, the heat-seeking missiles would end up coming at his house. So he needed this thing cooled down a little bit. And this is not an uncommon problem with these old Blackface Fenders. And I think we're going to find that it has to do with the plate dissipation of the 6V6. Okay, so let's take it apart and see what we can find. Hey Rusty, how excited are you about this Vibro-Champ? That much, huh? Okay, let's take a look here at the chassis from the Vibro-Champ. Notice that the rear plate is in just beautiful shape, that at some time a previous owner has seen fit to mark the tube sockets, which isn't the worst idea in the world, I guess. Now recall that this amp came into me because the owner claimed that it was overheating. That after operating it for 20 minutes or so, you couldn't even hardly touch the chassis without your fingers being burned. Now look here at the discoloration around the 6V6 and the 5Y3. Notice that dark heat discoloration. So it appears that his claims are very well founded. Obviously there has been some overheating issue with this amp that we need to figure out. But just one last pan here over the top. The numbers on the transformers, everything is exactly as it came from the factory, other than these little red letters which could be easily removed. Okay, so let's flip it over and take a look inside. Okay, let's take a look at the chassis of the Vibro-Champ. As you can see, the front faceplate's in just about mint condition. It has the blue indicator light, which is rather unusual. And notice that the set screws for the knobs are at 10, which is indicative of the early Blackface amplifier. The circuitry is absolutely original, pristine, untouched. I see no evidence of anyone ever having been into this amp or made any modifications. If you've got one of these and you want to put it back to original, this is the way it should look. Notice that all four of the cathodes of the tubes are bypassed by capacitors. Really immaculate. This is maybe the nicest original chassis I've seen on a Blackface Fender amplifier. Here I've spun it around so we can get a different vantage point. You can see the original potentiometers are all in place with their brass sheet to ground them. Original CAN filter capacitor, which needs to be tested. The death capacitor is still intact. Really spectacularly nice. Okay, let's take a look at this and try to figure out what's wrong with it. Okay, let's turn this beast on and give it a minute or so and see just how warm it gets. Let's see here. I'm going to turn off the camera and then turn it back on in about 30 seconds. Okay, this amp has been on for about a minute, and I can already feel the heat from the 6V6, the 5Y3, not so bad. 6V6 is unbelievably hot. Okay, now I don't know if it's responsible for the heating problem, but I haven't not seen many tubes like this. It's all black inside and obviously a 6V6 and just simply made in China. Okay, no brand name or anything else. I'm going to put in a good vintage American 6V6 and see if it heats up as fast. It should also be noted that this 6V6 tests out just fine in my Hickok tube tester. Has 2200 emission and no shorts, so it would seem like it's a good tube. Okay, here's a nice General Electric military spec 6V6 tested. It's used but not much. Let's plug it in and see if it heats up. Okay, amp is on, and I'm going to turn it off the camera for about a minute, same as with that Chinese 6V6, and then we'll check the temperature. Okay, more than a minute has passed, and I can comfortably touch this tube. It's nowhere near as hot as the Chinese 6V6. I'm wondering if that Chinese tube has some, it didn't register as a short, but it seems to be passing far more current than it should. Now I can quantify that. This is getting pretty warm, but nothing like the Chinese tube. And also, although there is no 120 cycle hum from this amp, I drained the electrolytic capacitors and then have tested them on the ESR meter. The 40 microfarad is at 1.3, whereas ideal would be around 0.5 or 0.6. And the 20s are at around 2 or 2.1, which is probably double the ESR value for a brand new 20 microfarad capacitor. But these values are well within acceptable limits, and the owner of this amp has told me not to change anything that doesn't absolutely need to be changed to preserve the originality of it. So I believe these old filter capacitors pass the test and are very usable. Okay, let's see what kind of current this Chinese tube is drawing. The bias resistor is supposed to be 470, and in reality it's 502 ohms. Now we'll use Ohm's law and seeing the voltage drop across the resistor to determine how much current is flowing through it. Okay, the voltage drop across it is around 25.5 volts. And the plate voltage with the Chinese tube is 384 volts. Okay, let's take a look at the results. And fortunately, they're just as expected. Cathode resistor 502 ohms, voltage drops 25.5 volts, which gives you a unbelievable 51 milliamps of current flowing through the tube. Plate voltage is 385, so the plate dissipation is very close to 20 watts. And since the maximum normal is around 12, this is getting up in the ballpark of double the acceptable plate dissipation. So I'll say a couple things for this Chinese tube. One, it flows a lot of current. And number two, it can tolerate some ungodly heat because the tube still works and tests out okay. Unfortunately, it overheats like mad. So let's do this same procedure again, but with that American tube. One other thing to consider with this Chinese tube is at 51 milliamps, I'm fairly sure it must have been red plating, but who would know when the inside of the tube is coated black? It's opaque. You can't see inside the tube to know if it's red plating. Okay, now I've got that GE tube in place, and we'll see that the voltage drop across the 502 ohm resistor, which was 25.5 with a Chinese tube, is now 21.6 volts. Now the plate voltage with this American vintage tube, the GE tube, is 388. So here's the results with the GE tube. It's the same resistance on the cathode biasing resistor. Voltage drop is less, 21.6 volts, 43 milliamps instead of 51, 388 plate voltage for a plate dissipation of 16.7 watts, which is still too high. So I'm going to increase this resistance a bit and try to bring this value down closer to 12. Okay, here's what I ended up with. The cathode biasing resistor I changed to a measured 802 ohms, and the cathode bypass capacitor did not check out well on the ESR meter, so I installed a new 25 microfarad at 50 working volts. Okay, then here are the results. This is the before with the Chinese 6v6 tube, which was dissipating close to 20 watts, which is, 80% over the maximum. And now with the GE, the vintage American tube, higher cathode bias resistance, that's a voltage drop. And now it's down to 31.5 milliamps, which is a manageable level, 403 volts. And the plate dissipation down near 12 at 12.7. Now, not all of the fault lies upon the little Chinese 6v6 tube. A big part of it is, and something you have to watch out for on these Blackface Fender amps, is they run at extremely high plate voltages. They just use a transformer that puts out very high voltage. Now, let's look at what would happen here. Say we have a plate current of 31.5 milliamps, which is a fairly high but normal and very acceptable plate current for a 6v6. But we say we're operating at a more normal plate voltage for a 6v6, which might be around 320, maybe 340, something like that. Our plate dissipation will be down around 10, which is actually below the maximum. So when you crank the plate voltage up like this, you're going to run high plate dissipation values. It's something you need to watch out for. Now, in the old days, when you're flogging your Fender guitar in the garage and your tubes are running at 20 watts of plate dissipation, I'm sure that all was just wonderful when you could go down to the corner drugstore and buy 6v6s for 89 cents a piece. But now that vintage tubes or any replacement tubes fairly expensive, also the transformers are no fun to buy for these. You really need to trim back your plate dissipation to compensate for the extremely high plate voltage. You're going to have to lower your plate current. And to do that, the easiest way is to increase the bias resistor value. Now, people may squawk and say, well, why not address the problem directly and lower the plate voltage? Well, that's not easy to do. If you put in ballast resistors or a bunch of Zener diodes or something like that, you can bring it down, but you're going to really fundamentally change both the appearance and the function of the circuit of this amp. It's a lot easier to change one resistor and reduce the plate current than it is to go and try to subvert the high voltage that's being put out by this transformer. Okay, so to me, this is the best way to solve the problem. Well, that about does it for today's video featuring about the nicest Blackface Fender amp I've ever laid eyes on. Okay, and I'm always happy when the repairs go well. In this case, we reduced the plate dissipation from a chassis melting 20 watts down to 12. The amp now functions just like it was intended to and is going to last a whole lot longer. This 6v6 and the power transformer will probably outlive us all. Okay, so I hope you enjoyed it. If you have an amp like this that's overheating, I hope you picked up some hints on how to solve the problem. And I hope that you join me again in the near future for the next video. Rusty and I are always busy cooking them up. So stay tuned and we'll see you again in the near future. Rusty, thank you for helping me with that video. You did a beautiful job. Okay, so why don't you just lay down now and relax. Okay, you've really worked hard. Good boy.